something about that. So here we have one of the best example for simple pendulum. So when we are talking about simple pendulum, then you can see this is my simple pendulum, and this is length L, mass M, and this angle is theta. So there are two type of periodic motion can be possible. So one type of periodic motion is just oscillatory in nature. Suppose you are just shifting the mass M or disturbing the mass M from the equilibrium point, and it is just doing this to and fro motion, something like this. This will be known as oscillatory motion. So it has something bounded kind of situation. But there is also a periodic motion when you will take it and you will rotate it completely. This is also periodic motion, but this is not a bounded motion. So how do you know that? When we are just going to plot the phase curve of this particular simple pendulum. Then obviously here we have the total energy of a system is basically P theta square upon 2ml square, where P theta is angular momentum, you can say. And here this will be minus mgl cos theta. So when we are going to plot the phase curve, this is our potential. So when we are talking about phase curve, we all know that we are plotting about momentum versus position, or generalized momentum versus generalized coordinate. Here momentum is angular momentum, position is basically theta. So before plotting to phase curve, we have to just plot first v theta versus theta, and then we can easily plot p theta versus theta. So here my potential is minus mgl cos theta. So you can see this potential will be something like this. This is periodic potential, isn't it? So this is periodic potential. You can have something like this. Now, and this value is something minus mgl, and this value is something plus mgl. And now we can easily plot the phase curve. So when we are going to plot the phase curve, then we have to plot p theta versus theta. So we can just extend it, and we can just plot p theta versus theta. And when we have energy between minus mgl to plus mgl, so we are talking about this much of energy or this much of energy you can take. You have always a bounded motion. You have always a bounded motion. Look at here. This is your bounded motion. You have a bounded motion, something like this. Okay. But if your energy is greater than mgl, then you have something like unbounded motion. Okay, the particle can, then this is just about, I am just talking about this rotation. So this is something like unbound, but it is also periodic. The same period will coming here. So you can have, suppose I am rotating clockwise, I can rotate it anti-clockwise. So angular momentum will change its direction, and you have this sort of phase curve. And yes, we can also plot the separatrix also. So this will be my separatrix. Okay, so this is a beautiful phase curve for your simple pendulum. So you can see the periodicity is there. So if periodicity is there, we can easily find the time period and angular frequency. There is nothing to do with the only small oscillation. If anything is periodic, then obviously you can find the time period. And here the Hamilton-Jacobi will help us to find the basically time period or natural frequency of some periodic motion. And here, when system is bounded, so this is your bounded system, then this is known as libration. It is also periodic, and this is your unbounded system, but it is periodic, and this is known as rotation. And if this libration is all about a stable equilibrium point, then obviously it is oscillation. Okay, it is not necessary that every periodic motion is all about oscillatory. Okay, you can have periodic motion, just find a suitable potential and you can find all these things. So you have to always take care of this particular definition. What is libration? What is rotation? Now, here with the help of action angle, we will try to figure it out what will be the angular frequency or simple natural frequency of any periodic motion. And what is meaning of periodic motion? Just we are repeating the same thing. This is all about period. So let's try to calculate just try to formulate the action angle principle. So everyone is comfortable up to this point? Okay. Okay. Chalo. So let's go for, and this is very interesting because this action angle will also the basic uh, uh, building block of quantum mechanics. So the Bohr-Sommerfeld theory is just extension of this particular action angle variable. So what we have, we can define a term J. We are just defining the term J, and this is also known as action angle variable, and which is given by a periodic integration. That means we are talking about one particular period, and this value is equal to what? P dq. So this is a definition of action. So once we are going to define action, then obviously I can write my P as a function of energy and Q, because your energy can be written as function of P and Q. So what you can do, you can write this P. So we can just go for writing this P as a function of energy and Q, and we can go for dq. So when we are going to calculate this particular thing, then this integration will be function of what? किसका function होगा? Energy, because आप Q के साथ इसे integrate कर रहे हो. So this J will be function of energy. And once we are getting this particular J as a function of energy, and you can also write this E as a function of J, then you can calculate del, and we will find that del E upon del J is nothing but frequency of a system. And the reciprocal of this one is nothing but the time period. So this is one of the very fundamental thing. Area under the phase space you have to actually calculate. Once you will calculate the area under the phase space, in a classical mechanics, this area under the phase space is basically continuous in nature. But yes, Bohr-Sommerfeld theory have told us that when we are going for the microscopic level, then area under the phase space is not continuous, rather it is discrete. But that will be the different story. We will discuss this thing into our quantum mechanics. But here, this is one of the very nice particular formulation from where we can easily find the time period or angular frequency or natural frequency of any periodic motion. And you have to do this integration for one particular period. Are you people comfortable? Everyone?
Yes, sir.
Okay. So let's try to go for some basic problem based on this action angle principle. So let's first we will go for a harmonic oscillator. Why? Because we know the final solution, and then we will verify whether it is working or not. Then we will go for some complicated problem. So what will be the frequency of harmonic oscillator? Anyone? If my potential is half m omega square x square, what will be frequency of harmonic oscillator? बताओ क्या होता है? ये तो बचपन में पढ़े हो. Omega upon 2 pi, isn't it? So this is frequency. Sorry, this is nu is frequency of omega upon 2 pi. We all know this thing, and this omega is nothing. You can easily find root under k upon m. So this is your frequency. Let's try to go for this. So when we are going to plot harmonic oscillator is nothing but beautiful parabolic potential. And this is my Vx versus x, and I can make it beautiful, okay, because it is symmetric. This is x. We can easily plot the px versus x. The px versus x is nothing but elliptical in nature. We all know that. So E is equal to basically px square upon 2m plus half m omega square x square. So we can easily calculate and we can easily see that when we are going to see the shape of phase curve, that means position versus momentum, and this is elliptical in nature. So when we are going to calculate this thing for the given value of energy, this is elliptical in nature, and this value is equal to nothing but root under 2m upon E, and this value of x, where momentum is going to 0, that is turning point. Actually, I am talking about this value of energy. So this is turning point, and this value is equal to 2e upon m omega square. So this is my minor axis and this is my major axis. So we can easily find this integration. And what will be the j? The j is nothing but for one dimension system, this is px dx. We have to go for one particular period. So then we can easily find, without doing integration, we can find what will be area. I am just going to verify whether my answer is correct or not. Then I will also tell you or discuss you basically that how we can do this integration also. Okay. So when we are going to do this thing, so what will be area under the ellipse? क्या होता है area under the ellipse? Pi a into b. What is a? Is basically 2e upon m omega square. What is b? Here is root under 2me. And from here, we can find this j is equal to 2 pi upon omega into e. This is your j versus e, and j versus e for the harmonic oscillator is actually linear in nature. This is also very interesting. This action angle variable versus energy is nothing but what? Linear in nature. Now, we have to write E as a function of j. So when we will calculate E as a function of j, that is omega j upon 2 pi. And what will be your frequency? Your frequency is nothing del E upon del j, that is exactly omega upon 2 pi, whatever we have learned in our +2 level, isn't it? Clear hai? Now, I will also discuss how we will do this thing with integration, because everywhere this you cannot write this particular thing pi a into b. Sometime you have to do integration also. So we have to learn how to do this integration. Clear है? कोई डाउट है तो आप पूछ सकते हो. चलो. So next thing is that we are just going to discuss how to do this integration. Okay, let's try to go for this. And this thing you have to remember, because this will be used into quantum mechanics, mainly WKB approximation and all Bohr-Sommerfeld theory. So at least one question will be there, either from the point of view of classical mechanics or from the point of view of quantum mechanics. The approach is exactly same. So you have to keep in mind the process of calculation. Okay, this is very important. So let's try to go for this. So here we have to calculate j, and this value is equal to px dx. Okay. Now, first target is that we have to write this px as a function of energy and x. So we will just go for writing the expression of energy. The first step, just write the expression of energy. Px square upon 2m plus half m omega square x square. So here we can easily write my value of px, and this value is 2m e minus half m omega square x square. Okay. Now, so this, when we will go for this integration, then we have to calculate the value that is basically 2m E minus potential energy. So minus potential energy is half m omega square x square into dx. So this is our J value. Now, what is your first thing? First thing is that we have to just go for doing this integration. So now if I am just able to calculate this area and I am just multiply with 4, I will just calculate the whole area under the ellipse, isn't it? So we will just write this particular thing. J is equal to 4 times 0 to x is nothing, but here this is 2e upon m omega square. And this value is equal to 2m e minus half m omega square x square dx. This is a value of J. Now, the next step. So first step, what you have to do? You have to write the expression of energy and then write momentum as a function of energy and position. And then you can see the symmetry of phase curve and you can easily write this particular thing. Sometime it may be between only for 1/2, then you have to go for 2 times of this one. Okay, suppose this is infinite and you have semi-parabolic potential, then obviously your particle will be only remain into the only x side. So you have 2 times. Okay, so you have to see the potential very carefully and then you have to calculate this one. Okay, so let's try to go for this. So now next step is that we are just going to make it dimensionless. So how we will make it dimensionless? The first thing, we will just take root under 2me common. हम लोग क्या कर रहे हैं? रूट अंडर 2me को कॉमन ले रहे हैं एंड देन वी विल गो फॉर 0 to root under 2e upon m omega square. Here we have 1 minus half m omega square x square by e dx. Now look at carefully. Whenever you will do this thing, this particular thing is exactly have dimension of, look at, sorry, this has dimension of length, then this particular thing is dimension of 1 upon length square. Then only it will become dimensionless. Are you getting my point? This thing is dimension of length square and this thing is dimension of length. This thing is also dimension of length. Okay, so now very carefully we have to substitute a new variable, and I am substituting new variable, that is value t. New variable में क्या ले रहा हूं? मैं ले रहा हूं t. What is this t? This t is nothing but root under m omega square 2e into x. You have to always keep x here, and accordingly you have to set this particular parameter such that this t will become dimensionless. Are you getting my point? अगर सपोज करो यहां x to the power 4 रहता तो क्या होता? Anyone? अगर सपोज करो यहां x to the power 4 रहता तो क्या करते?
m omega square upon 2e raised by 1/4.
1/4 और फिर लिमिट भी क्या रहता? 2e upon m omega square to the power 1/4. Are you getting my point? है ना? So इस पॉइंट और इस पॉइंट के बीच में डायरेक्ट रिलेशनशिप होंगे. Now let's try to go for calculating dt. So dt is nothing root under m omega square 2e dx. Okay. So this is your dt. Now we will put each and everything there. So what will happen when we are going to put this particular thing? Then let's try to go for this. So what we have j 4 time root under 2me integration, and yes, if x is equal to 0, t is equal to 0, and f x is equal to this one, t is equal to always 1. This is very interesting. When x is equal to 0, then t is equal to 0. When x is equal to this particular guy, this will be 1. So we will always try to write this thing from 0 to 1. Okay. So this thing will be go from 0 to, and you can just write root under 1 minus t square dt and integration 0 to 1, and this thing will come here, and you have 2e upon m omega square. Okay, this is all about 2e upon m omega square, and this is between 0 to 1. Okay, so this is all about between 0 to 1. Now look at here. If you are just watching this particular phase curve, very interesting. और इसको देखो हम ऐसे भी कर सकते हैं, बहुत फास्ट भी आप एग्जाम में करोगे. This is basically px versus x. This value is equal to nothing but 2me, root under 2me, and this value is nothing but root under 2e upon m omega square. Yes. And now if you have this type of value, now look at, if this will become a rectangle, then what will be area under the rectangle? अगर मैं इसे rectangle लूंगा, then what will be area under the rectangle?
root 2 me
into root 2e upon m omega square. Yes. So this is area under the rectangle, root 2me into this is 2 root 2e by m omega square. So this value, and I have to calculate this value, then can I guarantee that this value is some fraction? Agreed or not? फिर से मैं कह रहा हूं, अगर ये रेक्टेंगल होता तो इसकी एरिया क्या होती? यही होता, रूट 2me इंटू रूट अंडर 2e बाई एम ओमेगा स्क्वायर, और इस इंटीग्रेशन की वैल्यू क्या होती? 1 होती. But I have to calculate this area under this particular curve. Then I can guarantee this value is nothing but some fraction. आप agreed हो या नहीं हो?
Yes, sir.
Yes. So this value will be some fraction, and now you can see एग्जाम में अगर प्रोपोर्शनलिटी के टर्म में क्वेश्चन आ जाए तो जरूरी नहीं है कि इंटीग्रेशन आप करो, क्योंकि आपको बेसिकली जे और ई से मतलब रहेगा और बाकी किसी भी चीजों से कोई मतलब नहीं रहेगा. सो ऑलवेज ट्राई टू सी व्हाट आर द 4 ऑप्शन और व्हाट इज द एक्चुअल क्वेश्चन. अगर एक्चुअल क्वेश्चन में आपसे प्रोपोर्शनलिटी के बारे में बात किया जा रहा है, then obviously avoid this integration. Just think this is some fractional constant and you can do this calculation. But here we can easily do this calculation. How you will do this calculation? ये इंटीग्रेशन कैसे करोगे?
Putting t equal to sin theta and
Sin theta, you can just put t is equal to sin theta and dt is equal to cos theta d theta. And now you can easily calculate this particular value. So you can calculate j is equal to 4 times root under 2me into 2e upon m omega square, and this value is equal to between 0 to pi by 2, because if t is equal to 0, theta is equal to 0. If t is equal to 1, theta is equal to pi by 2, and this value is equal to cos square theta d theta. And what is this integration? वो integration क्या होगा? What is this integration? क्या होगा ये?
Pi by 4.
Pi by 4. So this j is equal to 4 root under 2me root under 2e upon m omega square into pi by 4, and you can easily calculate the value of j. That will be exactly match whatever we have done in last calculation. 4 से 4 cancel हो गया, and you have 2 pi e upon omega. Yes? सही है ना? And then you can write E versus J and you can find frequency. Okay. So let's go for one very simple problem, and then tomorrow I will do some more interesting problem. Okay. आज just basic concept को ठीक कर रहा है.
Sir,
हाँ बताओ.
can you please say the limits, sir?
This limit
Yes, sir.
theta is equal to 0. What is, sorry, t is equal to 0. What is value of theta?
Okay, 0, sir.
0. T is equal to 1. What is value of theta?
90.
90. That is pi by
Okay.
2. Okay. Are you happy?
Yes, sir.
Okay. Now, let's try to go for a particle of mass m in one-dimensional box of length L. Okay, the particle of mass m in one-dimensional box of length L. So, using the action angle variable, find the value of J as a function of energy. Energy is given. Okay, J as a function of energy, and then find the frequency. Okay. Obviously, it is also periodic motion. This is true and fro motion. It may be not oscillatory. जरूरी नहीं है कि oscillatory हो. Okay, and it is free. So the particle is free inside this box. So there is not any potential. It is just, it has just constant momentum, and it is just doing something like it will go here and come back. Okay, so let's try to go for this one. What is your J? Root under px dx. Okay, सही लिख रहा हूं ना? And when you will plot the basically px versus dx, कैसा प्लॉट होगा ये? श्यान बताओ कैसा प्लॉट होगा? For a free particle,
This is just a rectangular type of
the
plot.
rectangular type, it will go into this direction, and again when it will reach at L, it will go back, isn't it?
Yes, sir.
So this value is equal to what? Root under 2me, and this value is L. So we have our energy. Energy is equal to px square upon 2me. And what is this value? This value is minus 2me. Now we have to talk about the complete period. Means the particle will start from here, it will go there, and it will come back. So it will go there, change its momentum, and it will come back. So you have to find this complete area. So what is this value? J is equal to, and this is the closed integral. So what will be this area? Px dx क्या होगा ये? Area of the rectangle, isn't it? So without doing integration, we can find the area of the rectangle. What is this area of the rectangle? Root under 2me. This is 2 time we have to take. This is 2 time root under 2me into length L. You can do it with integration also. And from here, we can find J is equal to basically 2, and you can just find J square is equal to 4 into 2 me L square. So what is your E? E is nothing but J square upon 8 m L square. Okay, you can see E is equal to J square upon 8 ml square. Okay, so this is your E versus J. So if you are just going to plot E versus J, what will we plot? Kya plot hoga? That is parabolic in nature. Yes. This is very interesting. And if you have a knowledge of little bit of knowledge of quantum mechanics, I think you know that energy in a quantum mechanics is proportional to n square, isn't it? And energy in a harmonic oscillator is proportional to n. Are you getting my point? I am just giving you some intuition between action angle variable J and quantum number n. So it's a very interesting. This behavior of J is very interesting. How your energies vary with this particular J. And this J will be finally converted into quantum number in Bohr-Sommerfeld theory. Now, we can find del E upon del J. This is my frequency, and this value is equal to J upon 4 ml square. And again, we can write J as a function of energy because energy is the given parameter. So this frequency is basically, you can write this value as 8 me L square by 4 ml square. Okay. So frequency is actually here proportional to energy. Okay. And all this thing can be treated as a constant. So we have this frequency is √2 e to the power half upon this m to the power half L, isn't it? The frequency is proportional to e to the power L. Okay. And now you can see here, this frequency is a function of energy. This frequency is not constant. This is function of energy. It is very interesting. And we have also discussed that the frequency will be constant only when you have parabolic potential or your force is linear. Then only your frequency is constant. Otherwise, that will be always a function of energy. This is very interesting thing, isn't it? So you can easily calculate this thing, and anything of this particular thing, they can ask about the J, they can ask about this particular plot, they can ask about frequency as a function of E, they can ask about if energy will be double, what will be frequency? No? If energy will be double, what will be frequency? The frequency will change √2 time, isn't it? So this is very interesting. You can see this energy is, this frequency is proportional to e to the power half. Okay. And this type of question is always expected in your exam. Always expected in your exam. Okay. So I will stop this thing at this particular point. Tomorrow I will finish this topic. Tomorrow we will do some beautiful problem, little bit more interesting, the real application, and then we will finish this particular topic. Okay. Any doubt? कोई doubt है तो पूछ सकते हो?